In this video, we will be studying about the second method of measuring the dispersion, that is the interquartile range. Now, what is the interquartile range? It is the difference between the quartile 3 and quartile 1. So, the formula to calculate the interquartile range is quartile third minus quartile fourth. Now, the quartile deviation is equal to quartile 3 minus quartile 1 divided by 2. So interquartile range is quartile 3 minus quartile 1, whereas your quartile deviation is the measure of dispersion, that is quartile 3 minus quartile 1 divided by 2. The third we have is the relative measure, which is also known as the coefficient of quartile deviation. See, we used to do the range that was highest minus lowest divided by highest plus lowest. The same way is this Q3 minus Q1 divided by Q3 plus Q1. So this is the coefficient of quartile deviation. Now let's understand how to find out the quartile deviations in case of the different series, that is the individual, discrete and continuous series. Now this is the individual series given to us. Now let's understand how to calculate the quartile deviation. See, the method of calculating the quartile in case of individual series was n plus 1 divided by the fourth term Q3 was 3 into n plus 1 divided by fourth item, right? So here n is, how many numbers are there? 11 plus 1 divided by 4, that is 12 divided by fourth item, which is equal to the third item. So the third item here is 1, 2, 3. Third item here is 20. So this is your quartile 1. Now let's find out the quartile 3. 11 plus 1 divided by 4. This is 3 into 3, that is 9th item. So the 9th item here is 50. Quartile 3. So the quartile deviation is Q3 minus Q1 divided by 2. Quartile third is 50 minus 20 divided by 2, which is 15. So your quartile deviation is 15. Now the coefficient of quartile deviation we can find out. 50 minus 20 divided by 50 plus 20, which is equal to 30 divided by 70, 0.43. So your quartile deviation is 15, your coefficient of quartile deviation is 0.43. So this is the absolute measure of dispersion and this is the relative measure of dispersion. This is how you calculate the quartile deviation in the case of individual series. Now this is the discrete series we have. What we do in the discrete series? First we arrange the series in the ascending order. So we have already arrange the series in the ascending order, that is 10, 20, 30, 40. Then we find out the cumulative frequency. 2, 2 plus 8, 10, 10 plus 20, 30, 30 plus 35, 65, 65 plus 42, 107, 107 and 20, 127, 127 plus 28 is 155, 155 plus 26 is 181. 181 plus 16 is 197, 197 plus 2 is 199, right? So we find out the cumulative frequency. Now what we used to do to find out the quartile 1, we used to do n plus 1 divided by fourth item. So 199 plus 1 divided by 4, which is equal to 200 divided by 4, which is equal to 50th item. Now we used to see this item in the cumulative frequency. So your cumulative frequency 30 does not include this. So the 50th item is included in 65. That is from 30 to 35 is 65. So it is included between 30 to 35. 30 plus 35. So the quartile one is 40. So you got the quartile 1 as the 40. Now we used to find out the quartile 3 in the same manner. 3 into n plus 1 divided by 4th item, which is equal to 199 plus 1 divided by 4th item into 3, which is equal to 150th item. Now where does 150 comes in the cumulative frequency? It comes in 155, 150. So 70 is the quartile 3 we have got. So you got the quartile 3 as 70. So we can find out the quartile deviation, that is Q3 minus Q1 divided by 2, 70 minus 40 divided by 2, 30 divided by 2 is 15. Then we can find out the coefficient of quartile deviation, which is equal to Q3 minus Q1 divided by Q3 plus Q1, which is equal to 70 minus 40 divided by 70 plus 40, which is equal to 30 divided by 110. So it is 0.27. So we find out the quartile deviation and the coefficient of quartile deviation in the case of discrete series. Now we are given the continuous series. Again, what we will do, we will find out the cumulative frequency. 4 plus 10, 14, 14 plus 15, 29, 29 plus 20, 49, 49 plus 11 is 60. Then we will find out the quartile 1. How we used to find out? Then n by 4th item. N is 60 divided by 4 is your 15th item. So where does 15 come? In 29, 14, 15 does not come in 14 cumulative frequency. So it is 29. So your quartile class is 40 to 60. So your quartile formula was lower limit plus n by 4 minus cumulative frequency of the preceding class, that is 14, divided by the frequency into I, that is the class size. So lower limit is 40 plus n by 4 is 15 minus 14 divided by 15 into I, that is 20. So 40 plus 1 divided by 15 into 20, which is 40 plus 1.33. So it comes out to be 41.33 as your quartile 1. Now we have to find out the quartile 3. For that we used to do 3 into n by 4th item. So 3 into 15 is your 45th item. So 45th items comes here in this cumulative frequency. So this becomes your quartile class in quartile 3. So again we put the same formula, lower limit plus 3 into n by 4 minus cumulative frequency of the preceding class, that is 29, cumulative frequency, then frequency of the quartile class, that is 20, into I, that is the class size. So lower limit here is 60, 3 into n by 4, that is 15, minus cumulative frequency 29 divided by the frequency 20 into the class size, that is 20. So 20 is cancelled out by 20. So 60 plus 45 minus 29, it becomes 60 plus 16, which is equal to 76. So now what we've got? We've got the quartile 1 and quartile 3. So we can easily find out the coefficient of deviation, that is quartile 3 minus quartile 1 divided by 2, which is equal to quartile 3 is your 76 minus 41.33 divided by 2, which is equal to 34.67 divided by 2, 17.34 is your quartile deviation you have got. Now you can find out the coefficient of quartile deviation Q3 minus Q1 divided by Q3 plus Q1. So you can put the values of Q3 and Q1 and you can get the answer. So the answer is 0.30 approx. So this is how you find out your quartile deviation in the case of continuous series. Merits and demerits of quartile deviation. This is simple. Second is less affected by extreme value, because we are finding out the quartile, not the highest and lowest values. Demerits are not based on all the values. You do not take all the values, you take the quartiles. Formation of series not known. You do not know the formation of series. The third is instability. The calculation of quartile deviation is significantly influenced by change in the sample of the population. Accordingly, it suffers from instability. So, is there any change in the sample? So, the quartile deviation changes. These are the demerits and merits of the quartile deviation. I hope you have completely understood this. Do download our Scholars Learning app and enjoy the learning experience with us.